Today we'll be talking about the structural insulated panels known as SIPs, SIPs. That's these mountains here. They're the exterior walls and the roof of the house. They're made out of plywood skins with foam in the interior, and they go from the foundation clear up to the roof. The difference between SIPs and traditional houses is that there are no studs in this. There's just inside and outside skins and the foam in between. It's kind of like a really tough piece of corrugated cardboard. It's stiff and rigid, and it's just a panel. It doesn't have a bunch of sticks inside of it. This panel here is 8 foot long. As you can see, it's nothing but foam from one edge to the other, except where we've got two 2x8s of wood in the edge here. On top here, I've mocked up what a typical stud frame wall would have. Every 16 inches, there would be a wood stud. That means extra wood, and wherever there's wood, there isn't foam. So the SIP is more energy efficient, and it's more materially efficient as well. The other benefit to SIPs is that they're made in a factory, and then they're brought into site and craned into place. And we'll be looking at some of that shortly. That means that while the framing crew is doing something else, the SIPs can be made in the factory, and it can reduce the overall construction time. On this project, the SIP should be able to go up in about 2 weeks. So from the time they first arrive until the house is fully enclosed and insulated will be only 2 weeks. That's about twice as fast as you see on a normal house.
Well, I started out as a subcontractor for the Cascade Joinery, doing stick framing, and then they brought me in setting timbers, and then I kind of evolved into the SIP end of things. One of the main challenges is wind is a huge challenge, because you have a crane come out, and these things, you know, in retrospect, they're not very heavy in weight, and so you lift a big panel up off the ground with a crane, and then the wind catches it, and it tends to want to. It's just like a big sail, you know. We've done some stuff out in the islands where we had some real high wind conditions, and it shut us down a few times. No, we've never lost one. I've had them pick me up off the ground before when you're on a tag line. Well, you know, you kind of got a rope on it, you're holding it and trying to guide it in to where you're going to set it down on the roof. You got a guy on the ground with the rope, and then the wind catches it and takes the panel, and it'll actually lift it. Yeah, and it just lifts you off the ground. Yeah, exactly. But that doesn't happen very often. Usually if the wind's that bad, you know, we send the crane away and we start again another day. We pick it up, and then they've got the plates down over there, and we'll lower it down onto the bottom plate that they have down. That's already attached to the foundation, and we set the SIP slides right over the top of that. How you looking up there, Matt? Yeah, if you guys let us, you got 3.
Let's look at the anatomy of a SIP. It's a panel. This is a very small one. This is going up at the top of the roof. But it's got a plywood skin on the outside and an OSB skin, it's like plywood, on the inside, and foam in between. You'll notice it's quite thick. I've got almost 8 inches of foam here, and it's R3.5 per inch. I've got an R30 wall here. Your typical wall that's built to the energy code in the Washington State area is more like R20. So this is half again as good. And what makes it especially good is there's absolutely no gaps at all. The foam is solid from one side to the other. One of the things that really kills the energy efficiency of many houses is the leakiness from the inside to the outside. Later on we'll be testing this house's enclosure with what's called a blower door to see how tight it is. But if they do a good job today installing the SIPs, it should be almost virtually airtight. The outside skin is plywood, and it's made from trees that are certified to be sustainably harvested by the FSC, the Forest Stewardship Council. That's the toughest standard in the world. The foam is made out of EPS, that's expanded polystyrene. It's a white foam just like you find in, I don't know, when you buy a radio and you unpack it, or in your styrofoam coffee cup. It is foamed with a gas that is not ozone depleting or not harmful to global warming, which is not the case. Most foams have a gas that does one kind of damage or another to the atmosphere. This is foam just with steam, so it's quite benign. And then the inner skin is made out of OSB. That is made out of scrap lumber that other industries don't really need, and we make it into a useful structural panel. They're fastened to the timber frame with these long screws called SIP screws. So they go all the way through the SIP and into the timber. On this house, the timber frame is the structural skeleton. It's taking the gravity loads, the loads from above. The SIPs, on the other hand, are taking the lateral or the seismic loads. If there's an earthquake, it'll be the SIPs, not the timber frame, that does the resistance. The big benefit of SIPs is that the walls are solidly filled airtight with the foam insulation. However, plumbing and electrical still needs to run through the walls. So at the factory, they cut a slot vertically, and then periodically they have horizontal chases so that the electrician can feed his wires through there. For plumbing, it's always a good idea to keep it out of an exterior wall because it reduces the insulation and potentially the pipes could freeze. So all the piping for this house is on the interior walls, but the electrical, we're going to have to run through these chases.
I know it adds a little bit more frustration for, say, the electricians. If they haven't ever worked around them before, they have to get used to running their stuff in specific electrical chases and things like that, whereas in a stick framed wall they can just bring their drill in and pop holes. You like to keep the integrity of the SIP together as much as you can, and there are chases in the SIPs for the electrical. Yeah. And if the contractor goes over with the electrician beforehand, he can have the chases put in specific locations.
The SIPs come from the factory with a groove routed out for them. This is a doorway. Right next to me here is a window. Before the window or the door is put in, they'll fill that gap with regular 2x lumber. That way they can attach the window just as it is in a normal 2x wall.
How close are you to the corner?
Yeah, another couple inches over there.
You guys liking that? Can you push that your top out, Matt? Push yours out just a little bit more, Matt?
Yeah.
There it is. Yep. All right, you can let it in, Matt.
Nope.
Nothing, huh?
Here's the SIP panel, and you can see that this top plate here has been prepared for it. There's the mastic along both the inside and the outside edge, and then a zigzag along the top. It'll get placed in right like that, and once that cures, it makes a nice airtight seal.
You're trying to get an airtight house. That's the big thing with SIPs.
With these long screws called SIP screws.
No, we've never lost one.